This lesson reviews what happens in graph translations and stretching and shrinking. So a parent function of y equals the square root of x looks like this, so with points being 1, 1, 4, 2 is another point that's going to be on there, 3, 9, 0, 0. So what's going to happen if you have a negative sign in front of the root? It's going to flip it over so it's upside down. So it opens down. So this opens up, this opens down if it's negative. This value of a is going to stretch it. If a, stretch or shrink, I should read. So if a is greater than 1, it's going to stretch it. So it's going to go up faster. And a shrink is going to look like this. And then you can also shift it left and right and up and down. So if it's inside the square root, you're going to move it left or right. So if it's positive underneath the square root, you're going to move it to the left. So if you have the square root of x plus 4, it's going to be the parent function shifted to the left 4. And if you had the square root of x minus 4, it's going to be shifted to the right 4. Fell off. And then if it's outside the square root, or outside any of the root, it's going to go up and down and left and right. So if it's positive, it's going to go up. If it's negative, it's going to go down. So when we can put these together, left and right shifts and up and down shifts. So for example, if you're graphing this equation right here, this number is your a. This number is positive, so that means that your graph is going to open up and it's going to be stretched out, so it's going to open up a little bit higher. So if this would be the square root of x, this would be 2 square root of x. Because you're taking whatever you get for the square root of x and then you're multiplying it by 2, so it's going to be up a little higher. And then this means that you're going to go right 5 units, and this means you're going to go up 3 units. So let's look at this graph over here. So I went right 5 because of this, up 3, and it's stretched out vertically, and it's opening up. So let's look at what's going to happen with this one. Y equals the square root of x minus 4. So it's going to open up because it's positive in front, but my vertex of my root function is going to be right 4, up 1. So I'm going to go right 4, up 1. And it looks like that. So make sure you put an arrow, it's going to the right. And then this one right here, my vertex is going to be I'm going to the right 1, and I'm not going up or down. So it's 0. So I'll go right 1, up 0. And this time I'm stretching out by a factor of 2. Okay. And then right here, this means that I'm going to go left 3 and up 4. So left 3, up 4. It's my vertex. And here I'm opening down by a factor of 5. So I'm opening down by a factor of 5. So it's going to be really steep and going down. And you can get, I know that was a rough sketch, but you can get much more precise just by making a table. Okay, you can always make a table of values, plug in values for x, see what you get for y. Being careful that you're only plugging in values that are within the domain of x. So in here, we can't have underneath the square root be a negative number, so you always want to make sure that you pick numbers such that x plus 3 is greater than or equal to 0. So x has to be greater than or equal to -3. So maybe start your table at -3 and go up, and you can be a lot more precise with your graphs. Okay, D, so far these have been square roots, but here we have a cube root function. So y equals x cubed looks like this. So the inverse of y equals x cubed is y equals the cube root of x. And that looks like this. That's your standard function. So it's crossing at 1, -1 right here. Another point is going to be -1, oops, 1, what was I thinking? -1, -1. It's also going to cross at 8, 2, and then -8, -2, because the cube root of -8 is -2. So you're taking this general parent function. So I'm going to draw the general parent function. This would be 8, 2. This would be -8, -2. I'm going to draw a sketch of this. Oops. Yikes. I'll do that over again. So I'm going to start at -8, -2, 0, 0, -1, -1. And I'm going to draw a curve that goes through these points. So this is your general function. Well, now this means that it's opposite, so it's going to open down, and we're going to move down 3. So, and we're going to do left 2. So I'm going to go left 2 over here, down 3, and this is kind of like right here. This is kind of like my origin point. So this is my origin point. But this opposite sign means that it's going to go this way. It's going to be like reflected across the x-axis. So if I'm going to look at, see how this goes up? It goes up 1, right 1, this goes down 1, left 1. Well, I need to go opposite, so I'm going to go up 1, left 1, like this. And so my corresponding to -8 point's going to be about right here, and that one's going to be way over here. So it looks like this. And again, if you want to make values for x and y to be more precise, but in this case we don't have to worry about our domain because our domain's all real numbers. A cubic root function has all real numbers in it. So you could be more precise and pick values for this. And then down here, I think that we are going to skip this part of stuff in class because we're not using a calculator to solve for these. So we're just worried about the first part of this.